We have here a 2010 Mini Cooper. The customer brought it to us for a different problem, but it does have a check engine light on, and we're going to address that while it's here. We'll scan the computer system, see what trouble codes it has. And here's the codes with our little Foxwell scanner. We have 271B, DMTL heater, 272A, DMTL solenoid valve, 272E, DMTL pump motor, okay, we did scan this vehicle with our Foxwell tool and we did get some trouble codes, but the trouble codes are BMW specific and their definitions are a little bit cryptic using acronyms that I have to look up, and I'm pretty sure it's related to the evap system. It uses an acronym of DMFT. So I thought I'd scan this with my SOLAS Ultra. This is on generic mode. This is not, I do not have European software for the Snap-on SOLAS. So, but a lot of times the OBD2 codes, because they're so frequently used, they're a little bit easier to look up stuff with, because the trouble codes are more in more common use. And here's what we have. P2418 evap switching valve control circuit open, and 2400 evap system leak detection pump control circuit open. Since these are circuit codes, probably print a wiring schematic, look at the circuit, and see what is involved in the circuit. Okay, this Mini Cooper has a ginormous engine performance circuit with 4 pages. I taped them together as I always do for convenience and understanding. And DMFT is the Mitchell calls it the fuel tank leak diagnostic module. Pretty sure it's diagnostic module for fuel tank in the BMW terminology. So here at our fuel tank leak diagnostic module, we have a motor and a couple sensors, and this wire here goes up and has a fuse to it. So I guess this fuse could be broken. It would be pretty easy to check that fuse real quick. That fuse box is located in the front power distribution box. It is numbered as F05. We'll go check that next. So here's our underhood fuse box. It's supposed to be fuse number 5. And that fuse is good. I'll pull it out and inspect it. Looks pretty good. Look in the hole, don't see any problem there. Guess we'll rack the car and look for the problem at the leak detection pump. Diagnostic module fuel tank. Well, here is our diagnostic module for the fuel tank. That connector right there. We're getting ready to check voltages on this leak detection pump. There's multiple devices inside of it, and we're hoping there's no power to it, or maybe they share a common ground and the ground is a problem, because it's triggering trouble codes for 2 of those devices. So at this point, we're checking for power on this red and white wire, and I've got nothing. And so when I back probe that wire, I did get 2.5 volts this time. So maybe that's the entirety of our problem, or maybe I'm not in the right spot. Okay, probably should have took a better visual inspection before doing voltage testing and stuff, but I didn't spend a bunch of time. But there's a significant design flaw in this here car. This wire here, the leak detection pump, is mounted solid to the body of the car, and then this wire comes over here and is mounted solid to this bracket, which is mounted solid to the body of the car here. But then this wire comes over here and mounts to the swing arm that moves up and down. So I could imagine this thing making a sawing motion, and there does seem to be a little disruption in the harness right here. I can't really see anything there, but let's pull this out and open it up a little. And you can see there the harness is very frayed from rubbing, and the red and white wire is completely broken. And there's some green crusties in there too. I don't know if you can see that or not, but it's definitely green and crusty right in there. And there's green and crusty. There's a second hole. Despite the fact the wire is broke, there's a second hole right there rubbed through. There's green and crusty there also. Now I wonder, that was probably, I don't know why this wouldn't have shorted to ground. It seems like it would have shorted to ground and blew the fuse, but it didn't. I guess it just worn through, and then, yeah, it worn through, water got in, corroded, and then the wire broke. But here's the problem. This swing arm moves up and down, and they're securing it to the swing arm, yet it mounts solidly to the body here and solidly to the body up here. So that's a terrible design. I think after we repair these wires, we'll probably disconnect it from here and wire tie it to the leak detection pump and the charcoal canister, because it's mounted, all that stuff is mounted solid to the body. So let's get it off the... Obviously there's two wires here that need to be on the swing arm. One of them runs over here to the pad wear sensor right there, and the other one runs to the ABS sensor right there. So those need to be on the swing arm, but they're flexing with the swing arm as one unit. This one is mounted solidly to the body, then to the swing arm that flexes, and then over here it's solid to the body again. Terrible design. We'll fix that, the wire, and fix that and see if it fixes our trouble codes. After clearing codes and taking this Mini Cooper for a nice long road test, none of the trouble codes reoccurred. I'm going to call that a fix, and I've really come to enjoy working on these Mini Coopers. It's always a challenge and very rewarding when we fix the problem on it. This wasn't a tough diagnostic problem, but it definitely was enjoyable to see something that we haven't worked on before, and a nice fix getting that harness off that swing arm there, but it's really a bad design. If you want to see more Mini Cooper videos, click that like button and subscribe, and visit my website at www.kansascitytdi.com.